The random variable x has the following discrete probability distribution. And you can see our table. X's have values of 10, 11, 12, 13, or 14. Their probabilities are written on the next row. So we want to find the probability that x's are less than or equal to 12. Well, that would mean the probability could be 10, 11, or 12 because it could be equal to it. So we are going to add the probabilities for 10, 11, and 12 to see we have a probability of 0.7. Now finding the probability x's are greater than 12, not equal to, we could add 13 and 14's probability. Seeing we have a probability of 0.3. Now we have the probability that x's are less than or equal to 14. While if it's equal to 14, it would include 14 and all the numbers below that. Without adding it up, I would hope that all the probabilities would equal to 1, as all probabilities should equal to 1. But I can see that by adding 0.2, 0.3, 0.2, 0.1, and 0.2, it would indeed add to 1. This is different than finding the probability that x equals 14. So this is x being 14 and 14 only, which is 0.2. Now finding the probability that x's are less than 11 or less than or equal to 11, that equal to is important, or x's are greater than 12. Well, less than or equal to 11 would be 0.2 and 0.3. Greater than 12 but not equal to 12 would add in 0.1 and 0.2, which I see adds to 0.8. But perhaps an easier way to do this is notice that all of the numbers are in our probability except for 12. So that would be the same as saying the probability of x does not equal 12, or 1 minus the probability that x equals 12. This is probably more common, the 1 minus the probability, which is 1 minus 0.2 or 0.8. Perhaps a little simpler calculations there.